Welcome back. As you know, I am Eli, the computer guy, and this is our first parts bin video. So if you've been following along with this channel in 2024, you know that I've gotten fed up with the tech community. I am fed up with people talking about how AI is more dangerous than nukes and how it's going to destroy the planet and how everybody is going to have a quantum computer underneath their desk because that makes half an ounce of sense, right? I've gone to a lot of tech meetups lately, and basically people that have never deployed anything in their lives just will not shut the hell up about a lot of this modern technology and how it's gonna change the world, right? And so I sit there and I talk with the folks, and I'm like, well, that's interesting, but how do you deploy that? Question from the Aspie in the back. What is the API call for a nuclear arsenal? Oh, what does that mean? Well, I mean, if the AI is going to launch the nukes, what is the communication process? What is the protocol that allows that to happen? What? Right? And so basically for 2024 and probably going into the future, what I'm focusing on is actually building projects and showing you how to either solve problems or simulate solving problems. Again, getting you, halfway to the goal line with using all of this new technology. Again, whether it's artificial intelligence or whether it's quantum computing, IoT, any of that kind of stuff. Basically, actually sitting down and doing the brass tacks, right? Anybody can talk about how AI is going to change the world. It takes a little bit more effort to actually build something. So anyways, with these projects, one of the things that I need to do is I actually need to physically build devices, right? That's one of the things that gets left out in a lot of these equations when people are talking about all this new technology, right? There's this idea of code, right? Everything is built with code. Yeah, how's that working for your roof? Is your roof a Java roof or a JavaScript roof? How well is that working for you, right? But anyways, right? The reality is when you're building projects, you actually need hardware somewhere. Again, whether it's up in AWS's servers or whether it's having a little Raspberry Pi device, that type of thing, you actually need physical equipment in order to do the processing and the storage and be able to run the operating system and all that fancy AI code and that kind of stuff. And so basically, I'm building a different project. So this is one of my little IoT projects right here. And when I build these projects, I actually need to buy components. Now, in the modern world, right, not everything is brand name anymore. Like back in the day, you could go and you could buy Western Digital or Seagate or whatever else. One of the big issues nowadays is you go to Amazon and you just buy Chinese. Oh, who made that? China. I don't know. You just went there, spent $52. Got this thing in the mail. And so basically, since we're dealing with this world, and since I'm building this stuff while we're doing these parts bin videos, is basically to show you the actual hardware and how it works in the real world so that you can decide whether or not you want to purchase it. Think of this as like, what if Marquez Brownlee actually did a tech channel, not a gadget channel, right? That's what we're going for here. So anyways, with the projects that I've been doing, I started with some ChatGPT, some quote-unquote artificial intelligence projects, and actually being able to talk with the computer. And then I went to CES, a month or two ago. And when I was at CES, I ran into this company called Blues, and Blues builds what are called IoT modems. So basically, you pay $60 for this modem. You can connect it to an Arduino or to a Raspberry Pi. It comes with its own built-in SIM card system with 500 megs of data that will last for up to 10 years. So you do not pay data on a monthly basis, something like that. You just purchase the modem. It comes and will operate basically out of the box once you set up with their platform. And then past that, if you run out of 500 megs of data, you just simply toss them another $10. Whenever that happens, top up your system, and then you get another 500 megs of data, right? And so basically, with this little modem, I think there's a lot of cool projects that we can do. We've done a geo-tracking project with this. So basically we use this. It actually has a GPS system built in, and so you can track somebody like field technicians, that kind of thing with this, because it can actually be battery powered. We did communication systems, or we did the ability to turn on something like a power relay. So I created a web app where you can basically turn a power relay on or off. And again, this uses an IoT modem, so it's not Wi-Fi, it's not normal TCP/IP4 stack, and so you can turn something like a water pump on, an air conditioner on, a dehumidifier on, basically from anywhere in the world. And so the project that I wanted to do next, since we're pushing text, we're actually able to push text out, is what if we did something like a digital display system? And again, when we think about digital display, the difference between in the product, the actual product that goes out, really has a lot to do with form factor, right? So if you want a digital display, so like an advertising display, I could connect a Raspberry Pi to the Blues, to a 65-inch monitor, and then I could put up advertising. I could remotely send a message to show up and have advertising on here. One of the things that I was thinking about, though, is, again, in the modern world, I think about small, and I think about, again, like technicians out in the field and that kind of thing. And the thought was, well, what if we could come up with a communication system essentially to communicate, again, with somebody like field technicians? What if we could have a device that sits in a vehicle, so again, the technician's vehicle or the delivery driver's vehicle, and message could simply be sent and outputted onto a screen. So in that case, I don't want a 65-inch screen. I don't necessarily even want a 10-inch screen. Having a nice little 4.5-inch screen actually makes a lot of sense, right? And so that's what I have built here with this system. It's a little IoT messaging device with this 4.5-inch screen. Now again, FTC compliance, nobody is paying me for this. I do not get sponsors. Why do I not get sponsors? Because I'm honest, right? Anyways, but I actually bought this, again, last purchased February 23rd, 2024. I paid with this with my own money, and this is a 4.3-inch LCD screen that you are able to connect a Raspberry Pi to, and with that, you can actually have this whole little communications device, a computer device, that you can take along and can actually be powered by a battery, which is pretty cool. So let's go over to the other screen so I can plug this in and you can start to get an idea of what this thing looks like when it's running. So this is the screen itself. So you see the screen, and then on the screen, basically you screw in the Raspberry Pi 4 onto the back of the screen, and then you simply have a little monitor connector that goes from the display port on your Raspberry Pi onto the connector on the screen, and that's how it actually connects to the screen. So you're not using the HDMI connectors. So some screens use the HDMI connectors. You're not doing that here. You're not connecting USB directly to the screen. You're just connecting this one little strip here. Then on top of that, basically I've put in the Blues IoT modem on the back of it. This is the case. This is the case that you get. So you could theoretically put this on top. But the issue is when you put any hats on, these expansion modules, the expansion modules don't really fit too well in here, especially when you have the fan on there. And even though there's a hole, the pins don't stick far enough so you can put this on the outside. So one of the quirks here is that the screen works really well, and if you just want to use the bare Raspberry Pi with the screen, you can put it in the box, and that works well. When you start having the hat expansion cards, you might run into problems. One of the things I will warn you is you may be asking, Eli, why are you using a Raspberry Pi 4, especially when you own a Raspberry Pi 5? And so, I was not paying attention to form factors when I purchased the Raspberry Pi 5, and when I bought this particular kit. And one of the things you'll notice is the Raspberry Pi 5 looks a lot like the Raspberry Pi 4, except for, right? If you look at it, the power connector, USB-C power connector, is in the same place. The HDMIs seem to be in the same place. The GPIO pins seem to be in the same place. And a very cursory, when you take a look at it, it looks like the USB and the network ports are the same. but they're not. But they're not. They are reversed. So basically, the network port, I guess you would say, is on the bottom of the Raspberry Pi 5, and it's at the top of the Raspberry Pi 4. The USBs are swapped too. So, right, when you're looking at these holes in the case, yeah, you run into a good old-fashioned form factor problem. So again, this is just one of those random things you run into in the real world of technology. All right, so let me put this aside. Let's put this aside, and just to kind of show you how this little IoT project works, I can put this here, and literally, I just plug in a battery. So I just have a USB battery pack here, and this is powering the Raspberry Pi 4, the modem, and the screen. Now, when you're powering all of this off of the, see, you get that little thing that goes across. When you're powering all of this, all off of a USB power pack, you may get a voltage issue. I may show you that in a minute, where there's not enough voltage in order to run things like YouTube. You can run a web browser, and again, you can actually run Bottle. So I'm running Bottle web app framework for Python in order to do the messaging system. So that runs okay, and when you do the Chrome, web browser, that works fine until you go to something such as YouTube. Then everything kind of will go to hell. But the cool part is, I mean, take a look at this. Take a look at this. This is cool. Like, this is the full screen. Like, when I was buying a screen this size, I thought I would have to figure out how to configure my UI to even just show up on a screen this small. But as you can see, you got the Raspberry Pi button right here that gives you the normal Raspberry Pi stuff. You have the internet here. You have the terminal here. You can see you have the Wi-Fi, so connecting to a Wi-Fi. You can click on that. This is where we're getting that low voltage warning. But we can connect on the Wi-Fi to connect to different Wi-Fis. We have the time. We actually have the entire GUI interface that we normally do. Anyway, so basically what I'm going to do is I'm going to come here. And here I can actually bring up the terminal, my good old terminal. And then I have my teeny tiny little keyboard here. And so with this terminal, what I can do is I'm going to activate my virtual environment for my Python script. Then once I do that, I am going to run. This is the message client, so this is the client software. So I'm going to, Pi, I'm going to run that. So now Bottle is running. What I can do then is I can open up another terminal. This gets a bit wonky, and I'm going to open up this into kiosk mode. So what I'm going to do here is I'm going to go back. So what kiosk mode is going to do is it's going to open up the web browser in full, so people can't do anything else. So 127.0.0.1 colon 80. So I'm going to run this. It's going to give me that low voltage again. You can turn off that low voltage warning. I just have it on there so you can also see what's going on. And then now I have my message app. So this is being presented by the web server that's running, that Bottle web app server. And this is a script that is able to pull in new messages using this IoT modem in the back. If we go back to the main screen looking at me, I can then go, I have a web app running on here. So this is the Bottle web app running on here. This is my little messaging system. So I can basically put a message in here. So, hello, people watching YouTube. Basically what will happen is this message will get sent up to Blues platform, something called NoteHub, and then this IoT modem will pull the message down from NoteHub, and then it will display it on the screen. So I hit submit here, and then we look down here, and in a couple of seconds, we should see the message show up. There we go. Hello, people watching on YouTube, right? And again, this is a touch screen, so I can scroll back and I can see the old messages that are there. And so this is the kind of thing you can use a screen like this for, again, for things like IoT projects. So for IoT projects, again, you can simply use a USB battery pack like this and power all of this. You will get that weird little voltage issue, but again, you can silence that voltage issue. Just to do a little Google search and you can silence that. The issue when it comes up is basically if you try to run a resource-intensive website or app, something like YouTube. If you try to run YouTube using a USB battery pack, it'll kind of crash and log you out and you'll run into some problems. So let's take this apart. Let's take off the modem. So the modem isn't something that you might be using, so I can just take this hat off here and hopefully not bend any pins. Once I've done that, I can then take this. I can take I can take the case here and basically I can just slot this in. So take off the USB thing. I can slot this in here. And then that goes in. Kind of squeak it around a little bit. And now you have something, if you screw it in, I don't have the time to screw it in, but if you screw it into the back, you have something that looks much more pretty, much nicer, right? You have the power ports and all that kind of stuff down here. You have the USB connectors over here. And again, if you have a Raspberry Pi 5, what you'll notice, is that the connectors are different. This is actually flipped over under there, so the connectors are on the opposite sides, so you'll run into a problem with that. So anyways, now that we have this little thing, right, we can plug in our nice little keyboard. I have a little speaker here, right? A little $5 USB speaker that you can purchase, also from Amazon. And so with this, what we're going to do is we're actually going to plug this into a normal plugged-in Raspberry Pi power supply, so we do not have the voltage issues. And then I'll pull up YouTube for you, and you can see that even YouTube will fully run on this little thing as long as you give it enough power. So let me plug this thing in here. So we have just the normal power connector. This is going to a normal Raspberry Pi 4 power supply. I'm going to plug this into the USB-C, and now it should all boot up. I think it'll actually go this way when it boots up. And I'll put that behind it, maybe so it'll stand, right? And again, you got that nice little terminal screen that goes by, shows you that it's a real, computer. And now it's basically booted up and it's logged in, and we have the nice little GUI here. Again, if we, this is touch screen, so it is a touch screen that works fine. Again, we can click on this, we can go to programming. I actually have VSCode, it takes a second to open up, but you can actually click and do VSCode directly on here, because again, it's a normal Raspberry Pi, and you can install whatever other software or whatever you want to have run. It is pretty cool though. Let me actually do this, because when we open up VSCode, one of the things that I was surprised about is the resolution is actually so good that as long as you have pretty decent eyes, you can actually read it, right? So this is the code. One of the codes that I'm working on, blue-test.py, if you can read that. And if you sit here, you can see, port equals I2C, dev I2C1. The in card gives all the configuration information. And basically, this shows me basically all of the code, and you can read it and theoretically modify it from here. That's how good this thing actually is. Just to show you that YouTube will work, because I know that's like one of the most popular things. Nobody cares about VS Code, Eli. We want to see YouTube. So I can click on the web browser up here. This does take a second. So this is basically as fast as a 4 gig Raspberry Pi 4. So that's what you get. So I click on here, then I use my teeny tiny little keyboard and mouse combo here. So I do YouTube. So this will give me YouTube. I can click on that. Again, it's connected to Wi-Fi, so it's able to pull up YouTube or any other kind of web app as you want. And then, this is taking a second, so It's kind of hard also when I'm looking at it from here. So I'll go. This is one of the only issues here is that the address bar is so big and the header is so big, and then you got the bar up here. Like the actual viewport for YouTube itself is pretty small. So that is one issue. But we can click on this. So this opens up this particular video. I can then full screen it. And there you go. You have YouTube or whatever other video you want playing. Again, the speaker's working. So, oops. I don't know what's going on. There you go. So anywho, I don't know what the hell we're looking at here, but it shows you that the video does play well. You do get the sound out of it, and so again, something as resources intensive as YouTube works alongside VSCode or whatever web app or whatever that you want to have running. So there you go. There's your first parts bin video. This is an 800 by 480, touch screen, and as I showed you, it works shockingly well, especially for the size that it is. Again, it can display VS Code. It's up to your eyeballs about whether or not you can read it, which is pretty cool. Again, you can run YouTube as long as you power this thing directly off of a Raspberry Pi power supply. You can run all of this simply off of a USB battery pack, but again, you might run into those weird voltage issues as far as things like YouTube is concerned. If you're just running basic stuff on here, again, an Apache or an Nginx web server, you're doing like file services, that type of thing, you can run this off of a USB power supply, fine. You probably just want to turn off those voltage errors so you don't see them anymore. The issue is again, if you need to start ramping up the electricity usage and you're on a USB power supply, well, things might get a little funny from there. So again, it's one of those you actually have to test things out to figure out how well it will work for you. I absolutely love this. Nobody has paid me a dime to talk about this particular product. I just find it to be great. I spent, as you can see, I spent the actual $52 in order to buy this. And that seems pretty fine. You can buy less expensive screens, but you do get the nice little case with this screen. You get a little fan that comes along with it. You get the screen itself, and it works really well. So again, depending on what you're doing, right? If you're a high school kid and $50 is a lot of money, you might want to find a different option. If $50 isn't so much money, I would say just buy this thing. It works really well. One of the things I talk about, especially when we start dealing with IoT devices or things like network appliances, is one of the big problems we have in the Raspberry Pi or the Arduino world is you can configure one of these devices to be a very, very powerful, what is called an appliance, something that you plug into the network and you use. Maybe a file server, maybe a Pi hole, maybe a router, those types of things. The issue that you run into is you plug it into the network, it grabs a DHCP address, and then what do you do past that? Right. Again, if you've actually dealt with IoT devices, surveillance cameras, telephones, all kinds of things, that's one of the biggest problems. You plug it in, it grabs an IP address. The problem is you don't know what the IP address is. Now you get to go, hunt down whatever the hell the IP address is. What's cool about this is a full-fledged screen. So when this boots up, you can have it display what its IP address is. Again, if this is going to be like a Pi hole, so Pi holes are used basically as an ad blocking system, you could actually display specific statistics up here. Again, if it's a file server, you could do statistics, that kind of thing. So basically, you can design this so that not only can you simply plug this in the network and it works, but then it will present you with useful information so that it's easier to do troubleshooting and all that. Again, imagine when you walk into that networking closet or that server room and you have all these appliances basically screwed or super glued to a piece of plywood, and you're like, I wonder what that is. I wonder what that is. I wonder what that is. oh, this is going to be a bad day, right? Again, you got all this crap just screwed to this board. And I mean, it's TCP IP4, but beyond that, you might not be sure what the hell is going on. Wouldn't it be nice if every single device simply had a little screen on it to say, I'm a Pi hole. This is my IP address. These are my current stats. Wouldn't that be worth $50? And that's what I would argue. So that's the kind of thing you can do. The other thing with something like this, like I think about back when I ran my computer repair company, again, if you're still a field technician, imagine if you have a system like this and you use it either for a proxy server or for a file server. So you put on all the service packs, you put on all the antivirus software, and basically the files that you need. Imagine simply being able to plug this into the network at the client you go to. And again, it will simply pop up with this IP address and that information so that you just know what to use, right? You plug it in the network, it tells you what the IP address is, and then you can go to all the different clients, easily connect to the system, be able to download the files and do whatever it is that you need. That's the kind of cool thing that you can do with a screen. And again, I would argue it's definitely worth $50 if you have those $50. It just turns it basically the power of the Raspberry Pi just becomes so much more just with a nice little display like this that really does work very well. The only one quirk that I've really found with this that's really a quirk is with File Explorer. One of those things, I don't know why. I opened File Explorer once, and half of File Explorer was on the screen, and the other half of File Explorer was off the screen. And then I started having to push a whole bunch of buttons to try to get File Explorer to go away. Because the thing is, like, I couldn't move it down. I don't know what was going on. I couldn't move it down or reposition it. Like the X button was literally like here, and then the corner was down here, and that wasn't fun. So the only like real like, oh, that's a problem I ran into is if the window, you somehow expand the window outside of the screen, then that might be a pain in the butt. But, that'll be a pain in the butt almost no matter what kind of screen you use. Otherwise, I really haven't had any major issues with this. And like I say, I really do like it. So anyways, if you're interested, I'll put the link for this thing down in the doobly-doo. Again, before you buy anything, do your own research and the rest of it. I'm just telling you what my experience is. As always, I enjoy doing videos and trying to teach you folks about the world of technology and IT, and I look forward to seeing you in the next one.